So welcome to this latest video on 162 Maths, and in this video we'll be going over the GCSE Maths higher topic of trigonometry with the focus of going through some exam questions that involve a combination of using the sine rule and the cosine rule. Now, as always, I'll include a copy of the questions I go through in this video in a link in the description below for you to have an attempt at, which I strongly recommend you do so you can test your prior knowledge. Now, before we get started, let's just have a quick refresh on when to use the cosine rule and when do we use the sine rule. Now, for both these two rules, you use these rules when you have not been given a right angle triangle. So these for all non-right angle triangles. Now, we use the cosine rule when you know three sides and one angle where one of them is x, and use the sine rule when you know two sides and two angles where one of them is x. And a good top tip that I strongly recommend is if a triangle's been labelled not to your liking, so for example the A is not in the right place or B is not in the right place, then just simply relabel the triangle and draw a separate triangle if it does help, which I'll probably do as we go through some past exam questions. So starting with question 1, it says work out the area of the triangle above. Give your answer correct to one decimal place. Now, first things first, always check to make sure that you're given the height of the triangle. Now, in this question, we're not given the perpendicular height, so I can't use base times height divided by 2 or half BH. So I'm going to have to use the other rule for the area of a triangle. Now, the area of a triangle when you're not given the height is half AB sine C. So using this formula, if I label it, this angle here is going to be C, and therefore these two sides here are going to be A and B respectively. So substituting numbers in, so I've got area equals, and it's going to be a half times 14 times 6 times sine of 120. So I can just go straight into using my calculator, which I'm going to do right now, and I get an answer of 21 root 3, which as a decimal is 36.4, and that's to one decimal place. Moving on to question 2, it says work out the value of x in the triangle above. So again, because I know three sides and an angle, I'm going to be using the cosine rule. Now, because x is the side, I'm going to be using, and again, x squared equals, and then it's going to be b squared plus c squared minus 2bc cos a. So then labelling this side as little a, and let me actually start by writing that as a. This is going to be capital A, that's going to be b, and that's going to be my c. So substituting the values in, I get x squared equals 6.5 squared plus 8 squared minus 2 times 6.5 times 8 times cos of 43. So then simply entering all of that in my calculator, I get 6.5 squared and I get an answer of x squared equals 30.189. So clearly that's not going to be my answer, so I need to remind myself to square root. So therefore square root in that answer, it gives me 5.49447, and I'm just going to round my answer up to 5.5, and that's to one decimal place. Moving on to question 3, it says work out the size of angle y. So in this particular question, I've got two sides and I've got two angles, so I'm going to be using the sine rule. So again, just a little reminder of what the sine rule is going to be. So then substituting the values in, I get 7.3 over sine y equals 9.4 over sine 42. Then doing a bit of cross multiplying, I get 7.3 sine 42 equals 9.4 sine y. Take the 9.4 over to the other side, so I then end up with sine y equals 7.3 sine 42 over 9.4, and then what I then want to do is inverse sine the answer, And so typing that all into my calculator, 7.3 sine 42 divided by 9.4, and then inverse sine the answer, and I get 31.3, and that's been rounded to one decimal place. Then looking at question 4, it says, from a port P, a boat sails 46 miles on a bearing of 0, 34 degrees. It then changes its direction and sails a further 38 miles on a bearing of 164 degrees. How far is the boat from port P? Give your answer to the nearest mile. Now for this, we're not being given a diagram, so I need to draw one. So if I just pick a point and I call that P, then again with all bearing questions I need to draw a north line. And what I then need to do, now it doesn't need to be accurate, I don't need to get my protractor out, I just need to have a good estimate and try my best to try and draw as best of a diagram as possible without it taking too long. Now 34 degrees from north is, I'm just going to assume, is somewhere up here, and that's 34, and the distance is 46. So then from this point here, the boat then changes. So if I draw another north line, and it's going to be an angle of 164. Now 164 is somewhere along here, so I'll just assume that that angle there is 164, and I know that this distance here is 38, and the question's asking me to work out what this distance here is going to be. So as you can see, I can just about see my triangle, which this here is the triangle. And looking at that triangle, I know 3 lengths, but I need to work out an angle. Now I don't know an interior angle for that pink triangle, so I need to find that one first. Now looking at using the rules of bearings, that the north lines are always going to be parallel to each other. So if this angle here is 34, I could then work out this angle because they are co-interior or supplementary angles. So that angle is going to be 180 minus 34, which if I work that out gives me an answer of 146. So this angle here is 146. Now from that I can then work out what this angle here is going to be by doing 360 minus 164 minus 146. Now if I work that out, I get an answer of 50 degrees. So this angle here is going to be 50. Now if I take that triangle out, this angle here is 50. And again, don't need to worry about having it to scale or acute angles not looking acute. That's 38, and this is x. Now as I mentioned before, we've got 3 sides and an angle, so I'm going to be using the cosine rule. So then substituting numbers in, I've got x squared equals 46 squared plus 38 squared minus 2 times 46 times 38 times cos of 50. Now typing that all into my calculator, I get an answer of x squared equals 1312.81, and then working out x by square rooting that answer, I get an answer of 36.23. Now the question's asked me to round this number up to the nearest mile, so the answer then is going to be 36 miles. Then moving on to question 5, it says that a surveyor measures the angle of elevation of the top of a building from 2 different points on level ground that are 30 meters apart. Calculate the height of the building. So this is what I'm wanting to work out. This is h. Now I know that's 30, so what I can then do is, if I look at this triangle here, now in order to work out h, I need to know one of the sides of this right angle triangle here. Now the only side that's connected to the other triangle is this length here. So if I just take that triangle out, just do a very poor diagram, there we go, so that's going to be 24, this is 30, and this is what I'm wanting to work out. Now I can then work out what this angle here is, because that is on a straight line as it's on ground level. So this angle here is going to be 180 minus 35, which gives me an answer of 145 degrees. So this angle here is 145. So from this I can then work out what x is. Well, I know two sides of an angle, but the problem is, to use the sine rule, I need to know what this angle here is going to be. So if I just then work that out, which I can do because I know the other two angles. So this angle here is going to be 180 minus 24. Let me just write that a little bit nicer. Minus 24 minus 145. And that gives me an answer of 11. So looking at this, if I just label that as 11, so then using this side and that angle and 24 and x, I can then work out that x over sine 24 equals 30 over sine 11. So then doing a bit of cross multiplying, I get x sine 11 equals 30 sine 24. And so x equals 30 sine 24 divided by sine 11. So then working that out, I get an answer of 63.949. Now, taking that right angle triangle out, so I now know that this angle here is 35, this length here is 63.949, which is still on my calculator, and this is what I'm wanting to know, the height. So then using SOHCAHTOA trig, because it's a right angle triangle, this is h, this is o, and 35 is theta. So I'm going to be using sine. So I've got sine x equals x over 63.949, which again still on my calculator. So I get, actually it shouldn't be sine x, it should be sine 35. So x equals 63.949 multiplied by sine 35, and if I type that all into my calculator, I get an x value of 36.7 meters, and that's to one decimal place. Moving on to question 6, it says ACDB is a quadrilateral. The line from B to C is perpendicular to CD. The area of the triangle of BCD is 68.2. Find the area of the triangle of ABC. Give your answer correct to 3 significant figures. Now, to work out the area of the triangle ABC, I need to know what this side here is going to be. So let me just start by calling that x. Now we know that the area of the triangle is going to be a half times 16 times x times sine of 58. Now I need to work out x, so let's just start that by doing that here. So taking that right angle triangle out, we see we've got 11, we've got x, and what I need to do is work out what the other lengths are going to be. Now it tells me that the area of this triangle is 68.2. So that's B, that's C, that's D. So I know that the area of this triangle, which is going to be 11 times x divided by 2, equals 68.2. So then doing a bit of rearranging, I get 11x equals 68.2 times 2, which is 136.4. I can then divide that by 11, which gives me an answer of 12.4. So that means that x is 12.4. So then going back to this formula, so then all that's left for me to do is then enter this on the calculator. So I've got half times 16 times 12.4 times sine 58, and that equals an answer of, let me just quickly do that again, of 84.123 significant figures, and that's centimetre squared to 3SF. Then moving on to question 7, it says the diagram below shows a quadrilateral. A diagonal is drawn dividing the quadrilateral into two triangles. X is an acute angle. Work out the value of X. So let's have a look at working this one out. So first things first, what I need to do is I need to work out this length here in order to work out, to use the sine rule. So this triangle here is going to involve the sine rule, and this triangle here is going to be using the cosine rule. So first things first, what I need to do is I need to work out what this length here is going to be, which I'm just going to call y. So then to find y, I'm going to use the cosine rule. So here I've got A, B and C. So I've got y squared equals 14 squared plus 17 squared minus 2 times 14 times 17 multiplied by cos 58. And if I type that all into my calculator, I get an answer of y squared equals 232.758, and then square root that answer, I get an answer of 15.256. Then if I can swap that out, I can then write that as 15.256. Let's draw that triangle out again. Again, rather poor triangle, but and we know this is 11 and this side here is 15.256. I could then use the cosine rule to work this out. So I've got A, little a, B and little b. So what I've got then is 15.256 over sine x equals 11 over sine 41. Then doing a bit of cross multiplying, I get sine 11 sine x equals 15.256 sine 41, and then taking the 11 over, so sine x equals 15.256 times sine 41 over 11, and then x equals the inverse sine of all of that, which if you use your ANS function on your calculator, it should be a little bit easier rather than typing out everything anew. So let me just work that out. So inverse sine and I get an answer of x equals 65.5, and that's to 1 decimal place. And x is an angle, so let's put a degree there. Now moving on to our last question, it says do not use a calculator for this question, so it's going to be using exact values of trig. So let me just write that down. So exact values of trig needed. So in this question it says calculate the length of x in the triangle above. Give your answer in the form of a root b, where a and b are integers. You must show you're working out. So for this question, what I'm needing to know is to use the sine rule because I've got two angles and a side. Now the opposite sides are what I need, so I need to first of all work out what this angle here is going to be. Now because I know the other two angles inside the triangle, I can easily work that angle out by doing 180 minus 105 minus 45, which is 30. Now that makes sense because using the exact values of trig, I know 30, I know 45, but I don't know 105. So then using this as A, this being capital A, this is B, and this as C, let's substitute them into the sine rule. So what I've got is I've got x over sine 45 equals 10 over sine 30. Now doing a bit of cross multiplying, I get x sine 30 equals 10 sine 45. Now this is where, at this point, this is where I would introduce the exact values of trig. Now sine 30, if I just write this down, is a half, and sine 45 is either going to be known as root 2 over 2 or 1 over root 2, and it depends on whichever you do, and I'll go through using either. So let's start off by using sine 45 equals root 2 over 2. So then from this, what I get is x times a half equals 10 times root 2 over 2. Now knitting all of this up, I get x over 2 equals 10 root 2 over 2. So therefore x, because the denominators are the same, these two things must be equal, so x equals 10 root 2, and there is my final answer. If I was using sine 45 equals 1 over root 2, then it just becomes a little bit more complicated in the fact that I'm going to have to rationalise the denominator. So it then becomes x times a half equals 10 times 1 over root 2, which then becomes x over 2 equals 10 over root 2. I can then cross multiply, so end up with x root 2 equals 20. And then from this, what I can then do is x equals 20 divided by root 2. If I then multiply and rationalise the denominator, I end up with 20 root 2 over root 4, which is 20 root 2 over 2. I can simplify that to give me the same answer of 10 root 2, so x equals 10 root 2 on both of those, and that concludes the end of this question paper.